Good evening all, and let's solve the problem which was there on thumbnail. And these problems are very recently created by me. And let's see how to go about it. I'll start with the first one. Let f lambda with the family of circles. Now first we need to recognize what is this family represents. It's basically s plus lambda l equals 0. And just to recapitulate, if you have a circle equation x equals to 0 and a line L which intersects this at point, let's say A and B, and its equation is given by L equals 0, then the family of lines, then the family of circles passing through the point of intersection is given by S plus lambda L. Interestingly, even if this line doesn't cut, still it will represent a family, right? And of course that will not pass through either of the curve, but that will also represents family of circles which is somewhere not directly linked with circle in the line, right? So if I'll just plot the first family, so it's nothing but circle S is a point circle at 0 0 and is tangent to the line y equal to x, right? So we have family of circles like this. Second, T mu be the family of circles x minus 1 whole square plus y minus 1 whole square. So that represents another fixed point 1 comma 1. Interestingly, both of this point lies on y equal to x line, and with the tangent line is y equal to x. So let's draw their family members over here. There are infinitely many family members, right? Up down in both directions as well. So many of them will cut, many of them will touch, and so on. Now consider a family of a square S with vertices from set TTWW, PQ, UV. Now of course TTWW will lie on this line, y equal to x line. So we have a square over here. Just for the sake of clarity, let me draw this two family members here. So circle 1, circle 2. One is touching at 0 0, it touching at 1 1. So this is f lambda family member, and this guy is T mu. Now we are a square with vertices from this set where two of this point lie on the line y equal to x, and p comma q and u comma v is lying from fm and tn. Means two vertices of a square is lying on these two circle members and two vertices along the line y equal to x, right? If fm and tn be circles of same radius are touching each other externally, where fm belongs to f lambda and tn belongs to t mu, so they have same radius r, and for lambda, mu, p, q, u, v, r, all these are real numbers, and t and w belonging to 0 to 1 cross 0 to 1. It means I can take the value of t from 0 1 and w from t1. So that forces t and w to come from any point along this line segment, let's say AB. So now we have a square such that two of these vertices lie along line y equal to x and two vertices each along f lambda and t mu. So it's quite easy to see. We'll definitely have a square over here. The reason is I can make a segment of, let's say, length L such that these both distance are equal, right? It can be done because you can also think from the mean value perspective. In the extreme case, this rectangle will have area 0, and again in the lowermost extreme case it will again form a rectangle, right? So in between, definitely existence of a square is guaranteed when length and breadth is equal, because you are going from L equal to L to intersect at L equal to B. So there is existence of a square which is guaranteed over here. So you don't need to do any calculation as of now. So we have one square over here. Similarly with A and B, since radius is equal, so I can tell this distance is nothing but root 2r, right? Because this distance is root 2. And let's say if this guy is root 2, hence we'll have radius as 2r equals root 2. It means r equals 1 by 2. So with radius r equals 1 by 2, exactly the upper point of this diagonal, upper diametric point is going to form a square over here, right? So hence existence of 2a square is guaranteed. Exactly in the same fashion, we'll have 2a square for the circles which is mirror image along the line y equal to x. So in total, the answer for this problem is 4. So this was a beautiful question which was just based on understanding the meaning of problem and family concept. Let's come to the second problem. And it is, let's come to the second problem, and here we go. S is a set of all xy in R2. So in the plane says that y equals x square minus 15x. So it's some parabola. T is another set, x equals y. So it's again horizontal parabola. S intersection T is all the set of all points, so that xy belongs in S and xy belongs in T. So that is basically definition of S intersection T. Let x1, y1, x2, y2 and xn, yn be all possible n elements in set S intersection T such that they satisfy the set of equations xk minus alpha square plus equal to r square for k equal to 1 to n. It means all these points x1, y1 is having, which is common between these two parabolas. So let's say we have point A, B, C, D. So they satisfy the property their distance from a point alpha comma beta is r. So it's quite clear, like this property is nothing but it's giving hint for a circle. So there is a circle which is passing through all these 4 points. Now very surprisingly, this problem can be solved in one line, because if I'll just add these two equations, so let's say if I consider point A, it's going to satisfy set S. Also, it is also satisfying set T, because the coordinate of A, xa comma ya, will lie on both of these curves. So if I'll add these equations, I'll simply get x plus y equals x square plus y square minus 15x minus 9y minus 55 is 0 minus 55. And this is nothing but simply equation of circle over here. And this is nothing but equation of circle. So once you know equation of circle, you can calculate the value of alpha, beta, minus r. So it was a simple problem, but very nicely stated, as well as if once you can comprehend the questions, then you'll be able to solve it properly. Next question was, consider family of lines given as below. LP is 1 plus px minus py plus p times 1 plus p equals 0, and we have to find the orthocenter of this line. So here there is no smartness, but rather since L0 and L minus 1 will be quite easy, because L0 is going to be x equal to 0, right? And L minus 1 will be y equals 0. So this point will give you just 0 comma 0. So one of the coordinate axes. Similarly, now you can find those 2 points as well, and find the orthocenter by taking point alpha comma beta. So the slope of m1 m2 is minus. So this is left as an exercise for you. Then put the answer over here. In fact, you can calculate alpha plus beta, and as far as I remember, the answer will come out to be 10 or 16. That you can check. Right? Here we have a line L, which can clearly be drawn on the coordinate axis. Let F be the family of circle tangents to line L and also tangents to the line given by xy equal to 0, which is coordinate axis. C1, C2, C3 till Cn belongs to F. It belongs to family of circles with radius R1 less than R2 less than R3 and so on till Rn. Then we need to find the value of R1 plus R2 plus R3 minus R4. Now this is an interesting question, because what we can do here is we can solve this problem without any calculation. So first we'll see how many such circles are there. Clearly this is 4, 1 in circle, and we have 4 x circle over here, as you can see in this diagram. Right, now from this diagram is clear, because since this angle is 90, so the maximum value of radius is going to be R4, right, and the minimum R1 is over here. Now out of R2, R3, again, since this side length is 2024 and this is going to be 2025 y-axis, so this will be more. So, right, so we have R1, R2, R3 and R4, and now we need to find the value of R1 plus R2 plus R3 minus R4. So that's our target. I'll give you multiple methods of solving this problem. So method 1 will be just straight coordinate geometry. Well, I'll assume the center of this circle to be, let's say, R comma R. because it's touching the coordinate axis. Now r comma r takes care of both of this circle, in circle as well as x circle in the first quadrant. And what I will do is distance from r comma r to the line x by 2024 plus y by 2025 is 1. So using distance formula, we'll have mod of r by 24 plus r by 2025 minus 1 by root over 1 by 2024 whole square plus 1 by 2025 whole square is equal to r. So from here you'll get a quadratic. There is no need to solve the quadratic because I am only interested in r1 minus r4. So we can find the difference of root of this quadratic, right? If the difference of root comes out to be positive, so just you have to make it negative, because from this diagram you know r1 will be lesser than r4. So that instruction you have to give to mathematics. Similarly, to capture r2 and r3, r comma r is not enough, because if I'll keep r as positive, it will capture only first quadrant. So here I have to keep r comma minus r. Again, distance from center to this line is equal to radius, that's mod r. Will give again a next quadratic system, and now the sum of root will give you the value of r2 plus r3. And if you'll do this, very surprisingly, you'll get everything will get kicked off, and the answer will get a 0, which means r4, the radius of this largest circle, is sum of radius of this 3 guy. So that's method 1 of doing. Let's solve it in a little easier way, and here we go with method 2. So let's say if I consider this angle as theta, let's say this side is A and B. Okay, so I can write A as C cos theta, where C is hypotenuse length, and B as C sin theta. Now with this information, we can plug every value of this in radius. So r is delta by s. We know the r3 value will be, if I name it A, B, C. So r3 is delta by s minus b from solutions of triangle. r4 is delta by s minus a, and r2 is delta by s minus c. Right. So now you can put the semi parameter as, instead of a plus b plus c, we can write this into c times cos theta plus sin theta plus 1. And if you plug all these values, again you can show like the sum of radius is going to be r4. Method 3, which is a plus b plus c by 2, and you plug this information in this solution of triangle formula, where you are going to get everything will settled, and at last you can see is the sum of radius is going to be r4. But I'm giving you a very elegant solution, right angle triangle over here, as in problem statement, and I want to find the value of radius in terms of sides ABC. So I'm calling this side length as A, this is B, and this is C. Now we know if this radius is r, so this will definitely be r, because we'll have a square over here. So I'm going to take advantage of that. So what about this distance? It's nothing but b minus r. Since length of tangent is equal, so this part will also be b minus r. And hence using this, I can tell the remaining part will be c minus b plus r. What about this guy? It's clearly c minus b plus r. But this guy plus r has to give a. So this plus r is a, implies 2r is a plus b minus c. Now what is a plus b minus c? It's a plus b plus c minus 2c, which is 2 times of centimeter minus 2c. It gets cancelled, and in radius is s minus c. And that's interesting, because in radius value in case of right angle triangle is simply s minus c over here. Exactly in the same way, I'll show you how to calculate the value of the x radius. So let me take first x radius corresponding to opposite to angle C, and how to go about it. It's not very difficult, because again if I'll join its radius r, this guy is also r. If I take Again, this side length is A and B. So there's a small distance will be R minus B because full distance is R, right? This perpendicular distance. Since this is R minus B, so this tangential length is also R minus B over here. Right, so what about this small gapping? That a small gap will be full length C minus R plus B. Since that C minus R plus B, so hence this small again tangential gap over here because will be the full length R minus A. R is this distance and that's same as the point of contact of this X circle with x-axis measured along x-axis from origin, right? So this quantity must be R minus A, and that gives 2R equals A plus B plus C. And that's interesting because A plus B plus C is semi-perimeter, hence R is semi-perimeter. Which means in this case the radius corresponding to C, so RC is nothing but semi-perimeter. So we have RC equals semi-perimeter. Now let me show you what about radius when X circle is corresponding to this vertex A. So let's go with the same nomenclature of ABC. Exactly in the same fashion, if this radius is, let's say, RA, so this must be RA, right? So what about this full length? So this will be B plus RA. Now since this is B plus RA, so this has to be B plus RA full length minus the length of AB, which is C. So B plus RA minus C is just this tangential intercept with x-axis. So what about this length? It's like actually same, for the length of tangent being equal. But this length we all know it's RA by this diagram of being rectangle. Hence RA plus B minus C must be this entire length side A, which evaluates to 2RA equals A minus B plus C and S2S minus B. 2 cancels and RA is S minus B. And that's an interesting way because this radius is S minus B, and exactly in the same fashion you can tell this will be S minus A. Now equipped with all these results, we are ready to solve this problem in the easiest way. You could have fastened the method because once you know how to connect this, these radius can be calculated in a fast way. So now I can plug all these informations, whatever we have got. So here radius is semi-perimeter. Radius of this guy is S minus C. This is S minus B and S minus A. Now if I add these three radius, so we have 3S minus A plus B plus C, which is going to be S. And what is semi-perimeter? It's nothing but radius of that X circle, which is R4. So hence we have proved R1 plus R2 plus R. 2024 and 2025 was redundant and it was intentionally made. So one of the way in which you can solve these problems in examination is to scam. You simply take 2024 and 2025 as same thing by noticing the brain of questions. If you want more of these newly framed questions exactly as per JEE Advanced fashion, please do subscribe the channel because it's definitely going to add to your value addition for upcoming examinations.